Hello everyone, today we are going to learn about geometric sequences. A geometric sequence is a sequence where each term can be obtained from the previous term by multiplying the same non-zero constant. Sometimes it's also called a geometric progression. So a geometric sequence is really where instead of adding the same number every time, you're multiplying the same number every time. So r is the constant being multiplied. So just like D was the common difference, R is the common rate. So something to consider, it's usually easy to see if your R is, if every term in the sequence is being multiplied, let's say by 2. So we have a sequence like 2, 4, 8, 16, 32. So to get from one term to another, I'm multiplying by 2 every time. So my R is going to equal 2. Sometimes, though, your progression is going to look like this, where you have a sequence that might start with 110, go to 55, and then it would go to 27.5, which would go to 13.75, and onward. So it may be hard to see, but to get from one term to the next, it's probably easiest to see it here, you're dividing by 2. So to find my next term, I would also divide by 2. So the key to this is R cannot be division by 2. You have to write R as a fraction. If you're dividing by 2, your R would be the same as multiplying by 1/2. So division by a number is the same as multiplication by its reciprocal. So you need to keep that in mind when you're dealing with geometric progressions. So determine if the following sequence is geometric and explain why. We have 2, 6, 18. So it's clearly not arithmetic, because if you think about adding to get from 2 to 6, I would add 4, 6 to 18, I would have to add 12. So I'm not adding the same thing every time, which is why it's not arithmetic. To see if it's geometric, I would think about, okay, well, what am I multiplying to get from 2 to 6? To get from 2 to 6, I'm multiplying by 3. So then 6 times 3 is also 18. So yes, it is geometric, because it progresses using a common multiplier. Where R is equal to 3. So the equation for the nth term of a geometric sequence, ignore this, the formatting didn't come over very well, would be u of n is equal to u1 times r to the n minus 1. So remember, this is the nth term. u1 is the first term in the sequence. R is the multiplier. And n is the position number of the term. So consider the geometric sequence 2, 10, 50, 250. So we want to find the first term, sorry, this is a formatting issue, u1, and the common ratio of r. So the first term is obviously going to be 2. This is your u1, this is your u2, this is your u3, and your u4. Remember, the subscripts just tell you where you are in the sequence. So then the common ratio, we need to think about, well, how do I get from one term to the next? 2 times what equals 5? I'm sorry, 2 times what equals 10? 2 times 10. 2 times 5 is equal to 10. And then 10 times 5 is equal to 50. And then 50 times 5 is equal to 250. So the common ratio clearly is 5. So that sort of got deleted. Let's just keep that there. U1 is 2, R is 5. So we want to find the general term, U sub n, the nth term. So this means write an equation, right? So we want to do un is equal to our u1 times our r to the n minus 1. So this is using the formula from the previous page. And the n minus 1 is all an exponent there. So u of n is going to be equal to 2 for the u1 times 5 to the n minus 1. So right here is where you want to be really careful. You cannot simplify 2 times 5 because 5 has an exponent. Okay, so because of this exponent right here, the n minus 1, you can't take 2 times 5. Sometimes I see students make this 10 to the n minus 1. You cannot do this. Order of operations says this needs to be taken care of first. Since we don't know what n is, this is the most simplified form you can write this equation in. Okay, so still the same problem. Let's just, our u1's 2, our rate is 5, our general term was un equals 2 times 5, all raised to the n minus 1, and so we want to find the 15th term in the sequence. So that means we're finding u15. So it's going to be 2 times 5 to the 15 minus 1. Which is going to be 2 times 5 to the 14th, which is going to be a huge number, which is going to be 2. Now remember, it's not 2 times, I'm sorry, it's not 2 times 5 times 14, it's 2 times 5 to the 14th, so you're taking 5 times itself 14 times. So 5 to the 14th is 6,103,515,625. So then that's still times 2. So that'll be 12,207,031,250. So as you can see, geometric sequences increase much, much, much more rapidly than arithmetic sequences do. And that'll be the end of our slideshow. And we'll see you in class.